Welcome back. Let's talk a bit about recursive routing. We're at the point with the development of our Margarita smart contract where we're able to successfully stake DAI stablecoin into nearly any curve pool that accepts it. It's a great success, but we'd really like to make sure that our test is comprehensive and covering not just DAI, but every stablecoin on Curve. And this is a big and growing list. Curve is going to be supporting hundreds, thousands, maybe one day millions of coins, because people can launch whatever coin they like with the factory. Previously, we were able to accomplish this by looking at Brownie token tester and just minting whatever coin we wanted, but coins are getting launched too fast through this factory for Brownie token tester to be able to keep up. Fortunately, we can use Curve to actually just route assets to other assets on Curve and get a much more comprehensive list that way. And Curve has recently been dropping these V2 pools, which contain differentially priced assets. This opens up some complex routing options. At the time of this video, there's already 12 different assets, and by the time you're watching it, there may be significantly more. Each of these assets can be thought of as a bridge to various Curve V1 pools of that asset type. For example, you can think of it a bit like major subway hubs. If you're trying to get from, say, Convex to a dollar coin, you can hop on Convex, bridge to Ethereum through ConvexF, take the Ethereum, run it through TryCrypto, and then from TryCrypto, you could head to any dollar coin that you like through Tether. So there's a lot of complex routes you can build in, especially for the purpose of tests where you don't have to worry about the gas fees that you might have to pay. In order to demonstrate how this could work, we've built out a very simplistic recursive router. You can find it in the GitHub library under scripts, helpers, router.py, and we'll have to see how robust this is. It might be that by the time you're watching this video, Curve's upgraded its V2 pools in such a way this router is no longer working, but it's proven pretty resilient for the first 12 assets Curve is supporting. Essentially, it's working with the three different registries, the crypto registry, the registry, and the factory. If you didn't run through the alias, then you're going to have to enter the addresses directly. I've aliased them all to make my life a little bit easier. And we also look at a couple of special routings we'll talk about in a second. The max hops says how many different hops should we try and get to between one asset at the outset and the final asset. When you instantiate your pool, you're going to select a source coin. So for example, you're going to say, find me all the routes from DAI to every major V2 asset. These assets are loaded here in the load V2 coins function. At the moment I mentioned there's 12 different assets, but by the time you're watching this, there could be significantly more. Find crypto paths is the main function that we're going to be used to recurse from that starting coin. Look for all the nearest hops that happen to be V2 paths, as well as all available hops, and keep recursing that until it's gotten to the closest path that it can find through this routing between the initial coin and the final destinations. It will break if you go more than the max hops. We've set it to 3 by default, but you can update that as you initialize your router. Fetching the route is the basic function we look at to see if there's a routing between two coins. We are generally using the various registries find pool for coins function, but it breaks down in a couple of cases. For some common routing, we'd like to route, for example, the 3-pool LP token on lines 107 through 109 here. 3-pool is commonly used in a lot of the V2 pools, and it's easy enough to get there even though it doesn't show up in the registry's find pool for coin. Same with wrapping and unwrapping Ethereum. And here we just flush out the logic for 3-pool and the WETH wrapped Ethereum special case. The meat of it is in this recursion function. And recursion can sometimes break people's brains because you're passing the output of this function back to itself a number of times until the end criteria is hit. Essentially, our recursion function is dealing with 3 main variables. We have a routing dictionary, which we continue updating based on the results of this find routes function. And then we have a list of all the missing endpoints, which we shrink over time. And at any given hop, the most recent destinations that we're going to be feeding back into it in the next time. I've documented this extensively because I know recursion can be difficult to wrap your brain around, but if you want to take some time and struggle through it, it's actually fairly simplistic. Find routes, again, just goes through all the starting points, looks for an endpoint, calls the fetch route function here. And then finally, we have some functions to display. So let's see it in action. We'll fire up the console. And we'll start because we've started our script with die. We know that die is very functional with Brownie token tester. Let's build out a very simple die router. So I'm going to import the curve router function, and I'm going to create a die router, passing it simply die. And this is a little bit slow because of the way I did it. And if curve is going to add significantly more pools, you can only imagine it's going to get even slower. But in the very first hop, die was able to knock out 3 of the V2 endpoints. In the second hop, it found another 5. And by 3 hops, we found them all. If you'd like to see what they look like, the summarize function formats this quite beautifully. It's easy to get from die to tether. That's trivial. You can just run through 3 pool. If you want some of the more complex routing, though, you're going to need to, in most cases, move die to tether because tether is the most common endpoint using TriCrypto. Down towards the end, you see the more complex ones will then go from 3 pool to wrapped Ethereum, and then take the wrapped Ethereum, feed it into TriCrypto. At that point, you can hop to, for example, curve using the curveth pool, or convex using the convexeth pool. This works as long as your coin is within striking distance of any of these V2 endpoints. So, for example, you could create a convex curve router. The convex curve token is a wrapped version of curve that is utilized by convex, and you can't actually get directly to any of the V2 pools except for curve, but from that, within 3 hops, we can get nearly anywhere. So it's trivial to get there from curve, but once you get to curve, you can take advantage of F. But within 3 hops, you couldn't get to Euro, Tether, 3 curve, USDC, etc. If you'd like to actually use the routing, it's returned in a much more native fashion. If you simply look at the routes, it's going to return an index of the address of the destination, as well as the address in tuple form. The first version of the tuple is the pool you need to take, and the second is the coin you're looking to get out. So if you follow through this list, you have the routing successfully enabled. So play with it, try and break it, see how it does, see how you can build upon this to improve some of the routing in some cases. Curve V2 is building amazing things, and with this, maybe you're starting to see the genesis of exactly the power of what V2 can do.